When installing a subpanel in a separate structure, it's crucial to understand the proper grounding techniques according to the National Electrical Code. The primary consideration is ensuring a safe and effective path for fault current to return to the source, which helps to trip the overcurrent protection device, such as a circuit breaker, in the event of a ground fault. Connecting the subpanel's grounding system directly back to the primary panel's grounding system is the generally accepted and safest practice. This creates a single, unified grounding electrode system for both structures, minimizing potential differences between the two buildings and reducing the risk of electric shock. The National Electrical Code, or NEC, specifically addresses the requirements for grounding and bonding in separate structures. The NEC mandates that the grounding electrode system of the main building and any detached buildings or structures be bonded together. This is typically achieved by running a grounding electrode conductor from the detached structure back to the main building's grounding electrode system. This grounding electrode conductor must be sized appropriately based on the size of the service entrance conductors at the main building. In most residential applications, a number 6 American wire gauge or copper conductor or number 4 AWG aluminum conductor is sufficient for this purpose. The grounding electrode system at the main building typically consists of one or more grounding electrodes, such as ground rods, ground plates, or a metal underground water pipe that is in direct contact with the earth for at least 10 feet. The NEC specifies the minimum requirements for these electrodes and how they must be installed. When connecting the subpanel in a separate structure back to the main building's grounding system, it's important to ensure that the connection is made properly and securely. The grounding electrode conductor should be connected to the subpanel's grounding busbar, which is a dedicated terminal block for grounding conductors. From there, it should be run back to the main building and connected to the main building's grounding electrode system. It's crucial to use appropriate connectors and methods for making these connections to ensure that they are reliable and corrosion resistant. Avoid using methods that could weaken the connection over time, such as wire nuts alone. Instead, use listed grounding connectors that are specifically designed for this purpose. An important aspect to consider is the presence of any metallic pathways between the two structures, such as water pipes or gas lines. If these metallic pathways exist, they must also be bonded together to ensure that they are at the same electrical potential. This helps to prevent stray currents from flowing through these pathways, which could create a shock hazard or damage the pipes. The NEC specifies the requirements for bonding these metallic pathways and the size of the bonding conductors that must be used. In addition to the grounding electrode conductor, it's also important to install a separate equipment grounding conductor between the main panel and the subpanel. This equipment grounding conductor provides a low impedance path for fault current to flow back to the source, helping to trip the overcurrent protection device quickly in the event of a ground fault. The equipment grounding conductor should be sized appropriately based on the size of the circuit conductors that are feeding the subpanel. The NEC provides tables that specify the minimum size of the equipment grounding conductor based on the overcurrent protection device rating. It's important to note that the equipment grounding conductor should not be used as a neutral conductor. A neutral conductor is a current-carrying conductor that is used to return current to the source under normal operating conditions, while the equipment grounding conductor is only intended to carry current during a fault condition. Using the equipment grounding conductor as a neutral conductor could create a dangerous situation and is a violation of the NEC. In some cases, it may be necessary to install additional grounding electrodes at the separate structure. This is particularly true if the soil conditions are poor or if the distance between the two structures is significant. The NEC allows for the installation of supplemental grounding electrodes at the separate structure, but it's important to ensure that these electrodes are bonded together and connected back to the main building's grounding electrode system. The type and number of supplemental grounding electrodes will depend on the specific conditions at the site. It's always a good idea to consult with a qualified electrician to determine the best grounding solution for your particular situation. When installing a subpanel in a separate structure, it's also important to consider the voltage drop between the main panel and the subpanel. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it's important to use conductors that are sized appropriately for the length of the run and the amount of current that they will be carrying. The NEC provides tables that specify the ampacity of different conductors, which is the maximum amount of current that they can safely carry. It's also important to ensure that all connections are made properly and securely to minimize resistance. In addition to grounding and voltage drop, it's also important to consider the overcurrent protection for the subpanel. The subpanel should be protected by a circuit breaker or fuse that is sized appropriately for the load that it will be serving. The overcurrent protection device should be installed in the main panel and should be sized to protect the conductors that are feeding the subpanel. The NEC specifies the requirements for overcurrent protection and the types of devices that are permitted to be used. It's important to follow these requirements to ensure that the electrical system is safe and reliable. Finally, it's important to obtain all necessary permits and inspections before installing a subpanel in a separate structure. Electrical work is often regulated by local building codes, and it's important to comply with these codes to ensure that the work is done safely and correctly. A qualified electrician can help you to obtain the necessary permits and inspections and can ensure that the electrical system meets all applicable codes. In summary, connecting the subpanel's grounding system directly back to the primary panel's grounding system is the generally accepted and safest practice when installing a subpanel in a separate structure. This creates a single, unified grounding electrode system for both structures, minimizing potential differences and reducing the risk of electric shock. Always follow the requirements of the National Electrical Code and consult with a qualified electrician to ensure that the electrical system is installed safely and correctly.